Alright, here we go. So I'm just going to characterize the heating of this in several zones and across multiple measurements. See how accurate it is. Well, they all agree within whatever. I don't know why T2 is so low. It's probably because it's near the door. And the door is probably vented. Yeah. This is front to back. This is in the middle. This one's in the back. This one's in the front. Turns out doing measurements of an oven temperature is kind of difficult. I mean, you're measuring air, radiating heat, and this is also infrared. So you really need a target to measure. You can't just be measuring air temperature. But when I put it on the board, it was too hot, so I had to put it about a millimeter above the board and try to keep the thermocouples in place. Nope, wasn't happening. That's touching the coil. That one's touching the... I ran it underneath, and now it's touching the... Just have to leave it, let it cool, make sure it doesn't melt. Alright, I'm going to do another test and see if they go close to each other, but first I have to figure out how to not melt my wires. They were touching the damn... I got to tape them down. They were touching the elements. Yeah, these two are way off. I don't know why. These are way out. These two. I'm gonna guess because one's touching the board. Maybe I should put a layer Kapton on top of it. Push it in a little further so it doesn't touch. It's the same distance from the board. Yeah, this one's not touching either. This one's much hotter though. Maybe the back is that much hotter. Yeah, so they're both about a millimeter from the board. Yeah, see, they're going to close the gap now because they're closer. We'll put them both in the back. See what they measure. See if they track. Make sure it's not a probe problem. Right in the middle. They're tracking pretty good. I could do difference. It's a 8-degree difference. It's not too bad. They are pretty close to each other. That one's 200. They're all tracking pretty close. I mean, 10 degrees front to back. Well, not front to back, front to middle. Back is going to be way hotter. Only because you have so much air leakage. Once I put a gasket on here, it should be okay. 10 degrees out and then 10 degrees out from each other. So that's the variance. I'll have to average 2. I'll probably put 2 thermocouples in there and put them in parallel. Still 8 degrees out. It might have been 8 degrees out to start. As soon as it hits 420, I'll turn it off. And then I'm going to test this thermostat. Alright. The thermostat says 300. So it's totally wrong. It's holding heat really, really good. And it needs to cool. It doesn't need to hold heat that good. It's not too bad, 2 degrees per second, but it needs to go a little faster. If I had an air fan to blow on it. See why they're different. I don't know why they're drifting so far apart, those two. They've got to be touching. What's smoking? I don't know what's smoking. Maybe these probes aren't can't handle up to this temperature. Whoops. That's not good. I'm gonna have to get the metal braided ones. Yeah, they're 30 degrees out now. Those two thermocouples, and they're right next to each other. Maybe one's touching the wall, the wires. They're awfully pretty close. They're pretty close to each other. They're both in the air. They're both not touching the board. I don't know. I'll probably put my board in the front because the front warms up a little slower and cools down a lot faster. Yeah, both these thermocouples are... Yeah, this Kapton tape sucks. I'll have to get some real Kapton tape. Polyamide tape. This is just crappy. So yeah, Kapton tape, I don't know if they're all like this, but the cheap stuff, glue breaks down at like 300C. And the PTFE sheathed thermocouples are only good up to about 326. Which means their glass transition stage is probably a lot lower than that. I think the working temperature is about 190C. Alright, let that cool down and let's see where we're at. We're at I need to find the mark for what's the hold temperature for reflow? Soak is at like 150 to 200. So what is that? Right about there, 250. Seems to be more accurate at the bottom. This thermostat is not accurate at 400, at 300, over 400. So I'm probably gonna have to heat it up to there. Let the thermostat kick off, let it soak, and then crank it up. All right, not making s'mores. This is a marshmallow test. If you don't know what that is, it's to detect hot spots and cool spots in your oven. You can use it in the microwave. It's really good for using it in the microwave to find where the hot spot is. But I need to know where to put my board, and I do not want to put it in the worst spot possible and skew my results here. So we'll do a quick test and see which how much leakage there is in this oven. God. Ugh, this thing. These thermocouple wires are the worst. They're like springs. They're so hard to use. Exactly centered, but 135. They seem to be pretty even so far. Seems to do about it. I'll have to time this, but it's a little faster than 1 degree. Alright, so it looks like the back definitely heats up first. But not by much. Yeah. Let's call it. $222. I let it get too hot. The parchment paper burnt. Damn, this thing would get hot. Alright, we'll let it cool down. We'll take a look at what everything looks like. Even enough for reflow, I think. So I had the thought, let me see if I can turn this meter, it's a Unity meter, I forget the model number, into a logging or some kind of interface, because there is a Bluetooth icon on the screen that's not used, but and there's some test headers inside, so I thought, let me hook up to these and sniff them and see if they're anything useful. And it turns out there's not really anything but LCD breakouts for debugging the LCD header. So this was pretty much a waste of time, but it was a little fun. Reverse engineering and hacking on it just to see if I could get something useful out of there. It's a chip on board, so there's not really anything you could do as far as sniffing anything. There does seem to be some data lines coming out of it, but there's nothing on them. Most of it you'd have to somehow interface to all the LCD digits and decode it. Not worth it. I'll just get a different model or just build my own. Watch the temperature change based on what kind of power I supply to it. It's all based on how much noise and the kind of noise it's getting. It's bizarre. It took forever to figure this out. At first I discovered it when I was hooked up to Serial. Look, watch the LED lights come on and off. When I was hooked up to the Serial port, and anytime I would turn Serial on, temperatures would change. And I could not figure out what was going on for the life of me. Until I realized what the difference was between the readings sometimes. And sometimes it was okay. So right here I'm just turning Serial on and off, and it changes by 10 degrees. Such a simple change. So then I started scoping it, and eventually I just had to add some decoupling. I tried adding decoupling to my board with a bigger cap, and it didn't make any difference. So it's not my power. It turns out the max chip is the problem. Its power, or rather, the input from the thermocouple needs to be filtered. It's probably acting like an antenna. I think I put a several nanofarad cap on there, 1 or 10, I don't remember. I think the data sheet might specify it, and it fixed it immediately. So finally, I can get some software written to log and show me the expected temperatures and the curve, so I can manually reflow for now until I get an SSR and put it under its control, and then get some kind of PID loop or something controlling it. So this way I can at least start manually reflowing now that I have a decent monitoring system, temperature monitoring. All right, so we let it chill out at 140. That capacitor was already burnt. I took it off the board. Alright, slowly creeping up to 160. Soaking pretty good. It's been a minute. Start ramping it up. Got to start heading up to 210. Still soaking. I'll go up to 180 before we reflow. We're at 180. Might have climbed a little too fast. Get a little bit of reflow here. And we're going to cruise right into 210. And we're going to cut that off. Oh, that capacitor spun around. Alright, I don't think we ever hit reflow temperature, but that's safer than sorry. And we'll just start cooling down. I'm not sure if we reflowed good enough. I didn't let it hit 210, but these thermocouples might be a little bit out, so. Not too bad for just manually turning the knob when it hits certain points. So I'm happy with that. First reflow was really just a crappy test, and it succeeded, I think. Subsequent boards flowed pretty good. I've used it several times, and now I'm ready for full control, full automation. So, next part. See you then.